Well, thank you, folks, and welcome. I'm excited to kind of present on what it is that I'm personally passionate about. You heard a bit of the mouthful that comes with some of the research that we've delved into. I hope to break it down to the point where you can go home today and you can actually understand exactly what it is that we've focused on through our research effort and how it is that AnyLogic made this all possible for us. So I'll first give a quick intro. I don't see anybody else out there from Southwest Research Institute in the audience at the moment. Generally, when I bring up where I'm doing my research, it's unusual to run into people that are quite familiar with what we do. I'll give you a quick understanding of it, and then dive into the research topic at hand. I'll also address how it is that we utilized AnyLogic, and a little bit of a spoiler alert, it came to our rescue when we realized just how complex the scenarios that we were looking at were going to be, and just what kind of a time frame we were looking at in terms of being able to prove out the research work that we wanted to do. I'll go a little bit into the application and model, and conclude and open up the floor for any questions, and hopefully have some excellent answers for you as well. So, we have, of course, heard kind of the quick introduction of what it is that it means for Southwest Research Institute. We are headquartered in San Antonio, Texas. We are one of San Antonio, Texas' better-kept secrets. We do, for the most part, quite a bit of business, almost $600 million annually, and over 2,500 staff members, and we're stationed on 1,200 acres in the heart of San Antonio, which was granted to us by our founder back in 1947. So you can imagine having that much land in the center of an expansive city such as San Antonio. It gives us quite a bit of flexibility to do some amazing things on campus. And just a few of those amazing things, we focus on engineering research, specifically for the physical sciences. We like to say we do everything from deep sea to deep space, and then everything in between as well. I focus on a part there on the robotics, as well as the automated vehicle and connected vehicle portion. And we like to joke about it a little bit. We're a nonprofit organization, but we also like to say we're not for loss either. We do contract engineering, addressing some of those future problems. Some that are 3, maybe 5, some that are even 10 years out from being realized and being implemented in the world. So just kind of a breakdown on the autonomous capabilities at the Institute. This was an effort that has stemmed from almost a decade worth of work in autonomous vehicles. The Institute's been working back since 2006 on autonomous vehicles. We have, at this point, a number of vehicles with fully autonomous capabilities. This is potentially hands-off, driverless, free vehicles. The biggest, of course, being the Class 8 semi-truck, the Freightliner there in the upper left, affectionately referred to as Big Red. We also have a more commercially oriented, or a more consumer-oriented, pardon me, SUV, the Ford Explorer that we've nicknamed Marty. We have a number of military platforms, an 1165 Humvee, and a few others that we have autonomous capabilities and can execute missions with these UGVs. We also have a wide variety of UAVs, quadcopters. We do not refer to them as drones, but I understand that that's a term that's fairly well familiar for most people. We do refer to them as UAVs. That's their preferred term, of course. And now, thanks to AnyLogic, we have simulated agents in software. How would I summarize all of this? They have excellent capabilities in and of themselves, and they are truly awesome. My goal is, how can we make those awesome things even more awesome? So my effort stemmed around being able to take their individual characteristics and their individual capabilities and allow them to self-form teams and then execute on some larger system goal that would either otherwise not be possible for it to be executed, or would would be potentially inefficient in its execution. And the focus there, meaning that there is this synergy that could be achieved by all of these vehicles sharing information amongst themselves, distributing the estimate of their cost to perform a particular action, and then negotiating amongst themselves to exchange tasks, identify when particular agents are failing at some particular task, and instead engaging another agent to perform the requested task, and then moving on to determining whether or not the system goal could be achieved given your current team. So it became a very large challenge. It also became a bit of a focus on our effort. We needed to differentiate between some of the research that's already out there in terms of, say, swarm mentalities or swarm robotics, and a theme started to occur of being able to do this in a decentralized fashion. So in other words, make sure that these vehicles were not having to connect back to some central control area, some potentially vulnerable link in the chain of command. And with that's what sparked the creation of SyNRG. Now, SyNRG is a software framework that was built to allow intelligent agents to be able to exchange and represent the knowledge that they have within themselves from their observation of the environment. It allows them to form teams based on the various capabilities and coordinate some of the the distribution of some of the tasks that have been assigned for that team. And of course, it is, as I'd mentioned, distributed among the agents themselves. So our clients tend to be quite varied, and we needed to come up with something that would be an appropriate representation of the flexibility of SyNRG. We could pick one specific scenario. We could pick a domain of search and rescue bots that are all arriving at a scene and need to all contribute towards the identification and the rescuing of individuals in that disaster area. Or we could potentially be looking at clients that are trying to address more of a military problem of trying to reach targets that are maybe behind enemy lines. But we recognize that we couldn't have gotten to the full capabilities that were offered through this software just by focusing on one. So we came up with one that was a little bit of a hybrid. It covers quite a wide variety, but a blended kind of search and rescue with refueling allows us to show and highlight the flexibility while also being able to identify some of the modeling parameters that we needed in order to execute through the software research. So we included a wide variety of autonomous vehicles, ground, air, and of course simulated vehicles. We've recognized that the time frame that we had meant that we needed to focus specifically on the software implementation of these. That was a big part of the value that came from utilizing AnyLogic. And we also introduced into the world a kind of a world environment with an unknown number of, in this case, capsules. They are in at least initially unknown locations, and they all need to be fueled in some way. The vehicles all start out with a wide variety of capabilities. Okay, wide is a bit of a misnomer. For simulation purposes, we limited it down to 3 to 5. And we expected that we can expand from there, but we needed to be able to prove out the foundation first. Not all of the vehicles could actually refuel the capsules. Not all of the vehicles could identify the capsules. So we gave a wide variety of capabilities distributed amongst the agents in order to see what kind of emergent behaviors would occur through the usage of this simulation. There was a specified system goal, finding all the capsules, of course, and refueling them. And we can kind of break down what that looked like from the software perspective. I'll breeze through a bit of this. I think for the audience at hand, it's probably much more interesting to get down to our model itself And I'll just highlight a couple of items. You see here the representation on the physical systems. That is an ongoing research area that we're focusing a bit more on. But the time frame for us to get to this, when we started out this project, we looked at what we were presenting as far as what we wanted to do, and we looked at our budget, we looked at our time frame, and we saw very quickly that the other projects that were utilizing these resources, imagine that these very expensive autonomous vehicles are already very heavily used, and we couldn't just come in and say we need to set them aside and do our own research on them for months at a time, please. That didn't pan out too well. They have very important things that they are already slated to do. So we recognized that we needed to find some alternatives. I'll also point out that we did, at this point in the research, we do have everything set up as a very constrained set of system goals with tasks and prerequisites, as well as built-in priorities. It was outside of the scope of our research effort to try to do some sort of an ontology, something that could take a very generic system goal with, say, an English description of what was desired, and then break it down into the individual pieces. That's a very in-depth research area. If you're in that particular research area, I'd love to chat with you while you're here. But we focused more on the actual implementation of it. So the vehicles at this point could indicate their capabilities. They could establish a team that could perform the goal and the tasks that were indicated from the system goal, but getting them onto those vehicles. That was our big sticking point. Instead, we turned and we looked around at what kind of simulation packages were out there. And it turned out for us, AnyLogic was our clear winner. We'd run kind of an analysis of all of the options that were out there. We needed to be able to do agent-based simulation. We needed to be able to have a relatively robust but not complex physics interaction. We needed multiple agents, and we needed interaction potentially with large numbers of agents, all operating at the same time. We also looked at some traffic simulation. But in our scenario, though I work in the connected vehicle section, for this project at least, the traffic simulation models were not up to what we would actually want. Now, keep in mind, this was a couple of years, a year and a half ago by now, and it's pretty fantastic to see the ways that AnyLogic has progressed over the course of that time, and to see where it is today and compare it to where it was then. Boy, I don't know that there would have been much of a comparison needed at that time. So it's neat to see some of the things that are now offered, and some of the things that version 8 will bring for us as well. So we got down to the point of modeling intelligent agents in AnyLogic, representing a variety of capabilities. We also modeled a world environment. Now, looking back at it now, it's almost embarrassing how simplified it was, especially given some of the impressive 3D modeling that I've seen from some of the presentations this morning. But it was exactly what we needed for our scenarios, and gave us the opportunity to be able to vet the algorithms and the logic behind our research efforts, and got us to that point very quickly. So I'll give kind of a breakdown of our agents that we were modeling. We had kind of a generic vehicle in which we would represent the sensor horizon for that vehicle. It was expected that all of the vehicles had some sensor package in which they could experience the environment, draw in information about the things around them. They had some unique identifier for themselves as an agent ID. They also had a team ID. As those agents started to work together and started to form teams, you could determine which team a particular agent belonged to. They had links between the agents to be able to identify their communication, and some sort of a destination. indicated with the dotted line. It was very helpful for us to be able to see the route and the destination that the agents had selected in order to achieve the task that was being performed at the time. And they also had an indication of their current behaviors. I'll dive a little bit more into that as we get into it. And then, of course, we, being engineers, visually represented some of the debug information on screen in some of the rectangles that are shown there in the middle. So they'd start to change colors as they changed their behavioral sets, or they'd start off with a particular capability, and that capability would be represented visually. So it is, of course, in its essence, an engineering form of visually seeing what's going on with the model. We also utilized some of the state machine capabilities within AnyLogic. Originally, we'd looked at doing this just directly in code, and one of our more experienced modelers sat down and said, "What are we doing here? I'll just write it up in a state machine quickly," and kind of showed off that capability. Admittedly, it's a bit of a fairly simple state machine. I'm glad to see some of the more complex modeling efforts that are being undertaken by some of the folks here. And our sample into it just focused on the team negotiation and the efforts that went into building the team, and then focused on performing that mission while the vehicle was teamed with other agents. All right. So our environment, right? This is the conceptual representation of what it would look like to release these intelligent agents into some constrained world and allow them to interact with the environment, interact with each other, seek out these red dots, those capsules that we'd indicated in our example mission, and then potentially have obstacles in the way, the gray circles and boxes representing physical obstacles that could not be crossed as the agents are operating within this environment. We also learned pretty quickly to put boundaries around the outside, because in our first initial simulations, our agents, they wandered randomly, and it turned out they mostly wandered outside of our area of interest. So we couldn't really study those and their behaviors when they were off somewhere else. So in this example, unfortunately, I don't have an excellent visual model and video. In lieu of that, I will walk through some of the research and some of the steps that occurred as we dived into this mechanism of allowing these agents to interact. In this case, one of the agents is a searcher, and he has the search capability. The other agents do not have the search capability, and instead they have not yet been tasked. Because prior to being able to execute on a particular task, they have to have a task that fits their capabilities, and a capsule has not yet been found in order for them to do something with it. So they have the capability of interacting with a capsule. One of them may be able to identify. Maybe it has material classification algorithms that are running on the perception systems. Maybe another one has an additional fuel tank that it's able to utilize to refuel the capsules. And we see here in the bottom left in orange, because as an engineer, I love to be able to visually see what the agents are doing. The orange agent there is searching and is exploring the world and sharing the knowledge of all of the encountered objects that it has observed through its sensor horizon. And I don't know if I called that out a little bit earlier. The sensor horizon in our examples was just a semicircle in which we allowed it to sweep and be able to pick up encounters of that sweep arc with other environmental factors that came into that particular geometric shape. And the other vehicles in this case are waiting for a particular task trigger to occur. So then comes the real heart of it, the task distribution. That task trigger has occurred. There is a capsule that's been found, and the trigger is then sent to other teammates. It needs some sort of identification. It needs a classification to occur. An agent with the identify capability can then respond, plans a path to the object, and executes its task, and has also, in this essence, it has created its own cost model of what it will take for this particular agent to execute the task that's been requested. So much of our follow-on research work went into the determination of that cost model and the optimization and efficiencies of being able to potentially have multiple agents that could respond to this particular task, and to do so very quickly and in a dynamic fashion. And it turns out that was a large part of the value in some of the research work. So I'll show a couple of slides showing the model kind of in operation. In the upper left-hand corner, the vehicles as they're introduced into the system and as they're starting to explore the world and see what it is that's available. I also will touch briefly on this, but I recognized that our forays into a web interface that would allow people to see what it is that were being experienced by each of the agents is now being offered through some of the more recent AnyLogic features that have been presented. So it was exciting to see kind of how the work that we'd done in these areas was getting rolled into the main product line for AnyLogic simulation work. So yeah, the collaborative view of all of those agents contributing together to be able to see the world as it is represented, but by taking slices of each of the individual agents' experience with the world in the areas where they had traveled. So we also used some of the graphing capabilities and ran this with a wide variety of agents. We found that we could execute with up to 45 agents at a time with the hardware that we had, and we're able to convince a little bit more higher horsepower hardware capabilities for our next modeling efforts. And just to talk through and kind of conclude with some results, we had up to 45 agents operating simultaneously in an AnyLogic model. We were able to get optimized algorithms in execution and in development out of that simulation work. And the task distribution was a big focus of our efforts, and we were able to specify through our simulation work that we were able to achieve a new optimization mechanism for task distribution. And we were able to determine whether or not a goal was achievable. Given the number of agents that were currently in the system, could the system goal be achieved based on the cost calculations? We were likely 3 years ahead, maybe it's 2, depending on if there is another API commercially off the shelf available coming up soon for autonomous vehicles. But as of today, we do not yet have this on a physical system. That is the next expectation. But AnyLogic allowed us to be able to say that we could get to this point 2 to 3 years ahead of time. So I will then open it up for questions and answers. I appreciate everybody's time and your interest in this effort.
Thanks a lot. Very interesting talk. I guess my question is really simple. Can I have it? Can I use it?
Absolutely. We need to exchange business cards.
All right. So it's not like open source or something. You guys would sort of sell it and it's available.
So right, that's correct. Being research work, it is not open source, but we have a very open intellectual property policy. So we welcome discussions about it, and we believe that it can solve a number of difficult scenarios, and that there are a lot of research efforts, especially those that are fairly far out, that could be addressed through some of the solutions that we found.
Okay, cool. Thanks a lot.
Thank you.
How sophisticated or basic is the communication strategy? And just kind of, is there kind of a shared, do they write to a kind of a shared space? Do they send messages to each other? Are you representing, I don't know, intentionality, for example? Thanks.
Yes, a very good question. Yes, so in essence, we started with a fairly simplified mechanism of doing knowledge sharing, but we found that it was fairly straightforward. We focused specifically on the experience with the environment as the knowledge sharing concept. So if you imagine each of the autonomous vehicles has some representation of their world area that they've experienced, and that was the core of what was communicated between agents. In a fairly simplified form. It was expected that full communication was available, and we had a mechanism of being able to fuse, and I showed briefly on the screen there the slide that represented this fused world model of what it would look like. So each of those is a particular object that's been experienced by one of the agents, and that was the information that was communicated between the agents. So it started being very simple, but we were able to ramp it up to a little bit more complex communication and knowledge sharing effort. Any other questions? Well, thank you very much for your time.